What's negative?
So that means this first half of his is just like the one that I made, right? Where this collision causes this to go, and this is inelastic. Theta, or V0. This is V0 sine theta. And so the velocity, this up here, is going to be 2m times Vx. It's Vx. And that's going to equal, this has no momentum beginning, and then that's going to equal 2m plus 8m times V. Does that make sense?
What equation is that?
It's inelastic. It's just a collision. It's just momentum.
Oh.
M1 V1 plus M2 V2 equals M1 V1 final
And what's that?
plus M2 V2 final.
That's the same one.
Shut up.
Yeah. So you'll notice. Just take this equation, right? That goes away because it's not moving, and these two velocities, V1 final and V2 final, are the same. So I can just factor it out. It becomes M1 plus M2 times V. See? So it's the same equation.
And what's elastic? What's the elastic?
Elastic means they bounce off, and you just keep the two things separate at the end.
So this is
This is inelastic because they stick to, I'm assuming they stuck together.
Yeah.
Okay. So then, that means V is going to be equal, because the M's will all cancel, to Vx over 5. Does that make sense? Because, I mean, instead of 2 and 8, it could be 1 and 4. And then the total mass of 1 and 4 would be 5. That's why. So the 2 cancel, it divides out. So V is Vx over 5. So that means it has some kinetic energy. And the problem with this is that we need that height.
Wait, it shouldn't be Vx over 5.
This side by 10m. And now, to get this height, which we need, we have to use this original stuff, right? And so we can say, I'm going to use probably V, well, actually, you know what? Why don't I equal the potential G in the y dimension? So I get 1/2 m Vy squared is equal to mgh. M's cancel. I get h is equal to Vy squared over 2g, because we need this height to be able to do potential energy. Right? Does everybody recognize why I did this? Because we need to know how far this thing fell. I don't think they even realized to do that.
Right.
Or did you realize to do that?
Yeah.
Oh, okay, good.
But I don't know.
So now, that means up here, right, mechanical energy initial up
Where
here,
do you get that?
what?
Oh, okay. I got it.
And that's going to equal mechanical energy final down here, which is going to be 0, plus work done by friction. So the energy it has, what kind of energy does it have up here? Obviously it has, what kind of energy? Velocity energy? Kinetic energy, thank you. It has kinetic energy. It also has what kind of energy? Yeah, potential of gravity. And that's going to equal the work done by friction. So we get 1/2, and the mass is what, 10m? Yeah, the mass is going to be 10m, and then it's v squared plus 10 mgh, which is this. And then that's going to equal, I'm just going to say mu m, oops, just kidding. Okay, so then I v squared over 2 plus gh over mu g. And then this h right there, and then this v right there is this. So to finish, stick it in there and put it in there, and then you're done.
Wait, what? You get that 8 put in there.
It's your problem, not mine. I didn't make it.
It's crazy.
But once again, the key and why is this even remotely valuable? Because you're saying, when you look at something crazy like this, you say, okay, wait a minute, what's going on? Identify the issues, the problems, the physics. So first, this is a projectile, it's like a projectile 2D motion problem. Then it becomes a collision. then it becomes an energy, non-conservative energy problem.
So the last equation we used is energy.
Yeah, this was energy.
The whole thing was painful.
What's it? Painful, yes. Yes.
Why did you cancel out? You kind of
Oh, because it stops.
Oh.
Okay, any other questions?
I do have a question. Does it
Yep.
say v squared over 2?
Yes.
Can you move it?
Okay.